This is R.D. Sharma Solution Class 12 Chapter 18 Maxima and Minima. Exercise is 18.3. Now before we go ahead to solve this question, my submission is that how our previous exercise or previous discussion, we have come to a simplified version of same solution. Previously, when we wanted to find out the maxima and minima, what we used to do? First thing, see, whenever we have certain function, there can be multiple maxima. There will be one maximum among all the maximas. That is why we call them as local maxima or local minima. There can be minima, multiple minimas also. There can be one top of them, but all others can only be called as local minima, local maxima. So what do? F prime x or f dash x, we differentiate the function. The second step we used to take was we used to equate it to 0. When we equate it to 0, we get the critical points. So we mark those points. Let us say we have 3 points and we mark it on the number line from negative infinity to infinity. And since this f dash x is equal to 0 gave us these critical points, we go on the left and right. That is, when we want to find out in the interval negative infinity to infinity, we go to the left of a. So if value is coming in the f dash x, if we put this value a, we are getting positive, we put positive. When we place b, we can get positive or negative like that. So we mark positive and negative on the number line. Okay. When we say we are going from positive to negative, we say that we were already on the upper side and we are going to the lower side. So we were on the maxima. That point was regarded as the local maxima. And similarly, the otherwise condition is when we were on the below part and we are going to say uphill. So we say that we were on the local minima. Then we find out the value a, b, c. We put the values and we find out the value of y on this a, b, c. After finding out whether these a, b, c are the local maxima or local minima point. Now, in this exercise or in this discussion, same thing we'll do. F dash x equals to 0 till this point and finding out the critical point. But we don't have to draw a number line and find out the values in these intervals, whether it is coming as negative or positive. Plus, minus, plus, all these we don't have to worry about. What we will do is, we will double differentiate this function. That is, one differentiation is already been done, we will differentiate it twice. For example, if we were having x cube, we will differentiate it f dash x. We will again differentiate it f double dash x, that will be 6x in this case. And then we'll put the value a, b, c. For example, if we take certain numbers, if I want to explain it with certain numbers, for example, we have negative 1, 2 or something like that. There can be multiple numbers. So if we have negative 1, 6 into negative 1 is what? Negative 6. Now I told you that at a, that is negative 1, previously we used to find out the value on the left and right. And then we see whether we are going from plus to minus or minus to plus. But here in the second derivative, if it is coming negative, it's clear that this is the point of local maxima. Negative means maxima. Let us take one more thing. If we get b as 2, we are getting 6 into 2 as 12. This is the positive value. So we don't have to go on the left and right of b. Rather than, because normally we, in the previous exercise, we got 7 pi by 4, 3 pi by 4. There are so many different kind of values a, b, c we got, and going on the left and right, it was pretty difficult to understand or to remember what will be the value of these trigonometric values. When plus is coming, we will say it is minima. And so negative means maxima, positive means minima. And it is not minima or maxima. What is it? It's local maxima and local minima. Again, refer to that graph. Now that theory which we just talked about, we'll apply it here and you will see that how easy it will become for us to actually say whether we get the local maxima or minima, and we'll find out the value as well. Fx is equal to x raised 4 minus 62x square plus 120x plus 9. Next one is the differentiation. So I'm differentiating it. 4x cube minus 62 into 2 is 124x plus 120. This is a normal differentiation. We'll take 4 common. X cube minus 31x plus 30 is equal to 0. 4 cannot be 0, so this has to be 0. Now equating to 0 of f dash x is mandatory. Now x is equal to 1. Let us put it here. When we put x equals to 1, we are getting this as 0. So x equals to 1, that is x minus 1, is one of the factor of this particular equation. We need more factors, so we will divide it. That is, we will divide this x cube minus 31x plus 30 by x minus 1. And you know already this difference, division, but for the sake of completion, I am going to tell you. X square will multiply, so x cube minus x cube will come, x square will come, then let us subtract it. So x cube will be eliminated, x square will, I'm just shifting it on the left, putting this negative 31x and 30 on the right. Then just multiply it with x now. So x square minus x, again this sign can be changed, this gets cancelled. This is 30x, negative 30x plus 30. Now we need negative 30x, so we'll do what? We'll multiply it by 30, x minus 1 into 30. So we'll get minus 30x plus 30, change the sign, you'll get a 0. When you get the 0, that means we got x minus 1 as one of the factor and x square plus x minus 30 as the other part, from where we can devise what? The other two factors. So we have x square plus x minus 60, 30 can be 6 5 is 30 or 5 6 is 30. We can write it as 6x minus 5x. So now we can take this two factors, x minus 5 into x plus 6. So eventually this is all known to you, but for the sake of completion, these are the three factors. And I told you that we have to put it as 0. When you place it as 0 against these factors, f dash x equals to 0, that means x is equal to 1. You have to put all factors to 0. So x minus 1 equals to 0 is x equals to 1. X minus 5 equals to 0 is x equals to 5. And x plus 6 equals to 0 is x minus 6. Now we'll place this value. Normally we would place this value in the number line in the earlier versions. We'll take the values on the left and the right. We'll put the proper values, find out the sign. We'll check for the change in the sign, and then we'll say whether it is local minima or local maxima. But here you will see that we will double differentiate it. If you remember, this was our differentiation, first differentiation. I am going to again differentiate it. That is, I am going to differentiate this 4x cube minus 124x plus 120 again. It will give you 12x square minus 124. Now here we will place first of all 1, then 5 and then negative 6. In where? In the double differentiation. So when we put in the double differentiation, you will get 12 into 1 square minus 124, that is going to be negative. What will be the negative value? Minus 112. Now I am going to place 5 here. 12 into 5 square, that is 12 into 25 minus 124, that is going to come as 176. Negative 6 again, because it is negative 6 square, it will be plus. So 36 into 12 minus 124 is 308. I hope you got the idea. Now just see the sign. Negative 112 is maximum because it is negative. Local it is. I am just not writing local, but it is, these are all local. 176 is positive. That means it is local minima. 308 again positive. It is local minima. When we get positive, local minima. When we get negative, local maxima. The sign and the thing is different. Normally we say when it is negative, it is minimum. No, here it is inverted. Now what is the value for these 1, 5 and negative 6? We'll place this in the original function. So when I'm placing 1, it will be 1 raised 4 minus 62 into 1 square plus 120 into 1 plus 9. And this is going to give you certain value. That is the value of the function at x is equal to 1. At local maxima, what is the value of the function? That is y equals to fx. So this value will be the f1 value, which is coming from the original equation. So it will come as 68. Same way, we'll place 5 here. So 5 in the place of x, we are placing 5. 5 is 4 minus 62 into 5 square plus 120 into 5 plus 9. And that will give you negative, because see, these are the values which are coming from the original equation. Please remember, f dash x and f double dash x was just to check for the local maxima minima, but we have to find out the value also of the function. For example, f negative 6, if you put it, you will get minus 1647. When you place 5, it will be negative 316. So y is equal to fx. X is 1, 5 and negative 6. And that is how we got the 68, negative 316 and negative 1647. So this is the whole scenario. You can just pause it and have a look, or you can solve it by yourself. This is the whole scenario which we discussed. First, for fx, then f dash x, place f dash x equals to 0. You are going to get certain points which are the critical points. Now you don't have to go for the number line. Just take the double differentiation now. F dash x, double differentiation. When we are done with the double differentiation, now place these critical points 1, 5, negative 6 in this case into f double dash x. When you place these values, you are going to get negative or positive. If it is negative, it is local maximum. When it is positive, it is local maxima. And now once we have got this local maxima minimum value, now you have to find out the value of the function at these 1, 5 and negative 6. 68, negative 316 and minus 1647 will come. This is the whole scenario. This is the next question. And since we have just started the exercise, this question needs to be completed also, because normally if we are at the fag end of the exercise, I normally leave these type of questions because we have already done these type of questions. But here we have started, so we'll complete this question also. The first step is f dash x, differentiation. It will come as 3x squared, 6 to the 12, so minus 12x plus 9, for 15 will be eliminated. Now second thing will be f dash x equals to 0. We need the critical points. When we place it equal to 0, just you can take 3 common, because you can see 3 is common. X squared minus 4x plus 3. This x squared minus 4x plus 3 will give you the factors. So it will be x squared minus x minus 3x plus 3. You can take x common. It will be x minus 1 minus 3x minus 1. Eventually you got 2 factors here, x minus 1 and x minus 3. And when this is going to be 0, f dash x equals to 0 when x will be equal to 1 and x equals to 3. When you got x equals to 1 and x equals to 3, these value has to be placed in the double dash, double f prime, double prime x. That is, you have to differentiate the differentiation. Double differentiation I'm talking about. So f double dash x is 6x minus 12. This is the double differentiation. Now you have to place 1 and 3 in this double dash x, f double dash to f double prime. So f1 you have to find out with double differentiation, f double differentiation 3 you have to find out. So 6 into 1 minus 12, 6 into 3 minus 12, 6 minus 12 is negative 6, 18 minus 12 is plus 6. One time you got negative, so this is the point of local maxima. What is positive? It is the point of local minima. Local maxima, local minima you got. Now no graph making and no number line. Just place this 1 and 3 in the original equation in order to get the value of the function at these critical points. I am placing 1 first in the original equation, which is this. Now I am placing 3 in the original equation, which is this one. And these values are the actual function values. We'll get 19 in 1 and 15 in 3 when you place 1 and 3. Okay, so don't have to worry about the number line, don't have to worry about left and right situation. This is the whole scenario. So this is the reference in front of you. You can just pause it, have a look, try to solve it yourself. Next one is fx equals to x minus 1 into x plus 1 whole square. Now don't confuse here, because what you'll think is, oh, we already have the factors, we don't have to worry about anything. No, first we have to differentiate it. When we differentiate it, what does it mean? We have to take the differentiation. So rather than doing it like that, you have to take the multiplication. That is, you have to expand this particular fx. X minus 1 is already there, so I'll use the product rule for the efficient solution. I'm taken x minus 1, now differentiated x plus 2 whole square, next x plus 2 whole square, differentiated x minus 1. Now we can take x plus 2 outside, because this is common what we see. Inside you will have 2 into x minus 1, that is 2x minus 2. Inside this we have x plus 2, this can be x plus 2 here. Now what you see, 2x plus x is 3x, 2 gets cancelled. So what is the differentiation value, which is 3x into x plus 2. Better is to multiply inside, because we are going to go do the double differentiation as well. But when you put this equals to 0, the second step is f dash x will be equal to 0. This has to be placed as 0. When you place it equals to 0, this x will be 0 and x plus 2 will be 0. X, that will give you x equals to minus 2. So you have two critical points here, 0 and 2. Got the two critical points? The third step is to differentiate the differentiation. That is the double prime or double differentiation we have to do for 3x into x plus 2. That is why I was telling you that you need to multiply this inside. 3x square plus 6x. I'm differentiating it again. It will be 6x plus 6. 6x plus 6. Now what you have to do? You have two different values, critical values. So we'll have to find out f double dash 0 and f double dash 2. When you place 0 here, you'll get 6 into 0 plus 6. When you place 2, it will be 6 into 2 plus 6. First will give you 6, second will give you 6 to 12 plus 6, 18. Now both the time you have 6 and 18, that is the plus. When you have plus, that means, oh, there is a slight mistake. It's minus 2. What? That's my bad. So I'm going to put negative 2. 6 into minus 2 is minus 12 plus 6 is negative 6. So one time we got 6, other time you got a negative 6. Positive means local minima. Negative means local maxima. So in 6, see, this 6 and negative 6, we already got it. So I told you that you have to put this into the double differentiation value. We have placed it into 6x plus 6. This needs to be very clear. When we place 0, we got 6. When we place negative 2, we got negative 6. So positive means greater than 0 means local minima. Negative means less than 0, that is local maxima. Local minima, local maxima you got. Now we need to find out the value of the function at these critical points, which are what values? 0 and negative 2. So place this value 0 in f dash x. No, sorry, fx. Original equation. So fx, the fifth step is to take these critical points, place in the original equation. See, 0 minus 1 into 0 plus 2 whole square. So we can see here 2 square is 4, negative is already there, negative 1, so it will be negative 4. F negative 2 is negative 2 minus 1 and negative 2 plus 2 whole square. Negative 2 plus 2 is already 0. So when you multiply anything with 0 will be 0. So the first one f0 came down to negative 4 and the second one f minus 2 has gotten to 0. So we have negative 4 and 0. These are the value of the function at local minima and local maxima. And this is the whole process which you need to follow. This is the reference. This is a proper process you have to follow because you're going to write it as well. Logic, I told you, solution is your responsibility. You have to write everything because writing will make the examiner understand what you're saying. Next one is x greater than 0. You have 2 by x minus 2 by x square. So the first step is what? Find differentiation f dash x. When we do the differentiation f dash x, what are we going to get? See, differentiation is very clear to you. I don't need to remind you every time because you will say, oh, we can do the differentiation. But just for the sake of completion, it will be negative 2 by x square. Minus 2x square can be taken in the numerator. It will be x raised minus 3. Then you can differentiate it. Negative 3 will come in front. This 3 will go down as x cube. So what do you got? This is a simple differentiation I am applying. I'm doing nothing extra. First level differentiation. So what do you get? You can just take certain thing common if you want. 4 by x cube, or you can just replace or swap the places so that negative doesn't come in the front. I always deal with negative in between. That is what we have learned up till now. Second thing is f dash x has to be placed as 0. When you place this as 0, you will get the critical points. But what do you see here? X square is already there in the denominator. Why not to take the x square outside? 2 by x square can be taken outside. So this is 2 by x square. This is 2 by x inside. See, this is the way I am telling you. I am not binding you to follow this. It is up to you. You are intelligent enough. Okay, you are more intelligent than every one of us. So you can follow any way you want. So what I got is 2 into 2 minus x by x cube. See, the x is greater than 0. It is already given in the question. We cannot have x as 0. So 2 cannot be 0. Only 2 minus x can be 0. I am saying x is greater than 0. It is already given in the question. You cannot have x 0. 2 cannot be 0. So 2 minus x has to be 0. So 2 minus x equals to 0 is x equals to 2. So you got only one critical point, which is x equals to 2. When we got x equals to 2, what do we get? See, x equals to 2 has to be placed in double differentiation. So this differential has to be differentiated again. I am doing the double dash, that means double prime. I am differentiating it again. It will be x cube it's up to you. I always take this x cube and x square in the numerator, then follow the nx to the power n minus 1 differentiation, then I place that x raised negative to the denominator. So this is up to you. How do you do it? This is the whole scenario that you're going to find out. And then this in f double dash, we are going to place x as 2. So I'm now replacing x by 2 here. So minus 12 divided by this 2 raised 4, 4 divided by 2 raised 3. So when you simplify it, you can see that there will be certain value. This is, just let us simplify it by 4. So you get 3 by 4, and this is 1 by 2. 1 by 2 minus 3 by 4. So 4 minus 6 by 8. You get negative 2 by 8, that is negative 1 by 4. And we don't have to worry about value. We have to worry about the negative sign. Negative means local maxima. It's maxima. Local maxima. So when you got this local maxima, this is for the local maxima thing. But actual value can be only found from the original equation. So put this 2 in the original equation. 2 by 2 minus 2 by 2 square is 4. So you get 1 minus 1 by 2, that is 1 by 2. So that is half. So the value at this x equals to 2, y is equal to half. And we got at 2 the local maxima. This is the whole scenario. So now things are quite clear to you. This is how we are going to do it and write the content as per our requirement. This question will be taken in the next discussion. Thank you so much.